This lesson is about rational expressions. Fractions are rational expressions in algebraic form. That means we'll not just be seeing numbers, but we'll also be dealing with variables. Okay, so let's review some basic things about fractions, which are applicable both in arithmetic and when we have algebraic expressions. So when are two fractions equivalent? So if you have two fractions, let's say in this case a over b, and the other fraction is c over d, they are equivalent if you multiply the value of a and d, it should be equal to the value of c and d. So if you notice here, there's a condition that b and d cannot be zero, since we all know that we will not be able to divide by zero. Okay, so another thing that is useful is when you have a negative value in a fraction. So having a negative in the numerator is the same as having a negative of the denominator. Or you can also have the negative before the fraction. So you can rewrite all these three fractions are equivalent. When we write our final answer, we would like to write our final answer in what you call simplest form or lowest term. So in a fraction, when do we say that a fraction is in its simplest form? If the numerator and denominator does not have a common factor aside from 1. Okay. So if you look at this one here, you have a common factor of c. The numerator and denominator has factor c. So that means we can still simplify this as a over b. Okay, so that is in the simplest form. So let's look at some examples and express the following fractions in lowest form. So if you have it in algebraic expression, we need to do factoring. So like in the numerator here, for the numerical coefficient, our common factor is 2. So we factor out 2 and we write this as x minus 2. You divide everything by 2, right? Then for the denominator, if you remember, this is a perfect square and another perfect square. And our operation here is subtraction. So we have difference of two squares. Then we can factor this. We take the square root, x, square root of 4 is 2. So that's x minus 2 and x plus 2. So since we have a common factor, x minus 2, that means this is not in simplest form. So x minus 2 over x minus 2 can be simplified as 1. So that's the reason we are not canceling this out. If I would rewrite this, I can rewrite this in this form. And this whole thing becomes 1. Hence, we will have just the simplest form of 2 over x plus 2. So it is not being canceled out. So this symbol, sometimes other people would think that, okay, we are just trying to erase or disregard the x minus 2. It's not canceling out. The correct explanation is that x over 2 and x over 2, we can simplify that as 1. So any number times 1 is the number itself. So that's what is happening here. Okay. So let's look at the second one here. So we also have to check. So we have to see if this can be factored. So this is a trinomial, and if you look at this, this is not a perfect square. So that means you have to do trial and error. Okay. Now for the first one here, there's 1 as the numerical coefficient. So we don't have any choice. It's just 1 times 1, and the variable is x. And this is a little bit easier because there's only one factor for 3. It's 3 times 1. Okay, so what does this mean in factoring? This means that we have opposite sign. Okay, so that means one is sum and the other one is difference. Okay, now since this one is negative, I will try out the bigger value assigned with the negative and the smaller number positive. Then we can double check by doing this inner and outer multiplication. Okay. Okay. And when we simplify, we have negative 2x, which is what we want in our middle term. So hence, we have the correct factor. Okay, now in our denominator, 3 minus x. Okay, now we cannot simply cancel this because this will not be equal to 1. But there's a way for us to either rewrite this or rewrite the denominator. Because if you compare, the only thing that is different between this is the sign. Like x here is positive, but x here is negative. Here you have negative 3, but here the sign of 3 is positive. So how do we try to rewrite it in this form? We can factor out negative. Okay, so what we're trying to do is to divide by negative 1. So positive 3 divided by negative 1 is negative 3. Negative divided by negative is positive. So what I am seeing here is that if I simplify this yellow expression, it's just equal to this 3 minus x. I think you would agree, no? If we do the multiplication, the reverse process, I would get this thing. So why did I do this? So that you would get the same thing, no? So I can just rewrite this as x minus 3. Exchange the ordering. If I exchange the ordering, I'll have x minus 3, which is what we have here. So that means x minus 3 and x minus 3, if we simplify, that's just 1. So we will have in the numerator, we'll be left with x plus 1 over in the denominator, negative 1. Don't forget the negative. We did not simplify. No, this is not part of the simplification of 1. 1 is just this. So you still have negative, and we can easily distribute the negative so that we have a nicer final answer without the fraction. Okay, so you can do this. Okay, so please be careful on this type of problem. Okay, so this is another tricky problem because some people would simply, okay, I have x minus 3 and x plus 3 and x plus 3. We can just simplify that as 1. So let me just clarify that these are not equal. These two are not equal. I'm going to write down something else on top. Okay. So parenthesis use in algebra is very important. These two, they are not equal. When we have this problem, then of course we can simply now cancel x plus 3. But this is not doable here because we're just multiplying x to the quantity x plus 4. So if you compare it, for this problem on top, I'm multiplying x plus 4 to the entire quantity x plus 3, which is not the same as what we have here. So now, what do we do? Okay, so if you look at this problem, there's nothing to factor. So let's see what happens if we just multiply the x here. Okay, so let's look at what will happen. For the numerator, we have x plus 3. Then let's multiply x and see what would we get. Okay. So upon multiplication, we see that we're going to get a quadratic function. Okay. Now, again, we have to repeat and see if the denominator will be factorable. Okay, so if you look at this, this is not a perfect square, so that's not square of a binomial. So, but this is x squared, just 1, so that's x times x. Okay, and then look at this one here. This is positive, means you have to have the same. I'm using either both positive or both negative. So I will be following this plus. Okay, then the factor of 3, we only have one option. 3 times 1. Okay, and when we reach this point, here we have the quantity. So now we can cancel this and we can simplify this as 1 over x plus 1. So these are some of the things, the second one and the third example, that you have to be careful. Okay, sometimes we mislook because we are in a hurry solving a problem. Okay, now we're going to do the operations next. So first is we'll do multiplication and division, because multiplication and division, it's just for the multiplication, numerator times numerator and denominator times denominator, straightforward. Then we just see if we can simplify this in lowest term. Okay, then for division, you're familiar, you're going to take the reciprocal of this second fraction, right? And then instead of multiplication, we have times and then the reciprocal. Then again, from this part, it's just a basic multiplication. So numerator times numerator, denominator times denominator. Okay? So here, what you can do is you can already factor it, no? Instead of doing the simplification at the end. Okay, so if you look at the first fraction, there's nothing to factor here. So it's just simply a minus b over a minus 3d. Now, since this is division, I have to change the operation to multiplication, but I'm going to get the reciprocal. So that means this would become the numerator. Now, instead of just copying that, I will check now if I can factor this. And if you look at the term, this is a perfect square, and this is another perfect square. So I'll just factor this, square root of that minus the square root of the other one. Okay. Then, for the denominator, for this one, this goes to the denominator since we are doing a reciprocal. So same thing, we're going to factor this one. So again, a perfect square minus a perfect square. So that's d minus a. And we have d plus a. Okay, so let's see if we can simplify or cancel something. So here we can, I think there's only one thing that we can cancel, right? Then for the final answer, we have to multiply this again. So I'll just write it down first here. So you cannot leave your answer in this form. You're going to multiply this. So you can do the long multiplication. Okay, I'll just do the short. You can do the FOIL here, inner and outer. We simplify. So this is 3 and negative. So that's positive 2ab. If you don't know to do if you can't do the FOIL, you can just do the long multiplication. Negative 3b squared over d squared minus d squared. Okay, now in the second problem here, it's a combination of division and multiplication. So same thing as what we did on the first example, I'm going to already see if I can factor out the numerator and denominator. So obviously for the first one, there's nothing to factor. For the second one, we have a common factor of z. So we factor that out, then divide, so that will be z minus 3. Okay, again, a perfect square and a perfect square. Okay, so take the square roots of both. Then for the denominator, okay, here we have a common factor. Okay, so we both have a. A is a common factor. Let me use a different color for the common factor. And then for b, b cubed, b squared, it's b squared. Okay, and then of course both of them have z. Okay, so this is a common factor. So when we divide, you only have b cubed over b squared. So that's b in the numerator. So this is divide by this one. Plus, okay, so this is the same thing, right? So when we divide, we get a 1. Okay, then again, I'm going to do now the reciprocal. So this one will be in the numerator. So again, you have a common factor, z squared. So if I factor that, you have b minus 1. Okay, so this is the common factor. And then here again, we are dealing with common factor AB. But I will be writing this in the denominator. So you'll be left with here z plus 3. Okay, so we're just going to look for factors in the numerator and the denominator that are equal so that it will be equal to 1. So which are they? So it's this one. That's 1. Okay, what else? Here, when you multiply z squared, I have z in the denominator and z. So that will become z squared. So they will now become 1. Okay. This is, oh, sorry, no, this is minus, this is plus, so we cannot simplify. Here, we have z plus 3 and z plus 3. Okay. Now, you can just multiply first, or if you want, you can try to simplify. You know, like this one here, I have 2a, which will be a squared, right? 2a here if you multiply a squared. And then you have here a b squared and a b. So when you multiply, that's b raised to 3, which is also in the numerator, you have b raised to 3. So at the end, we just have b minus 1 over b plus 1. So this is our final answer. Okay, so it's more of factoring and simplifying when we're doing multiplication and division. But when we are doing addition and subtraction, then we have to do more steps. Okay, so for the first one here, I have addition and or subtraction. So it's just the same when you do addition or subtraction. It would be very easy if you have the same denominator. So if you have the same denominator, I'll just give an example. I'll just go back to arithmetic. Like for example, if you have 1/3 plus 5/3, then that will just be 6 over 3. Okay, so as long as we have the same denominator, we can just add or we can just subtract our numerator. So what is a little bit more challenging is if our denominator are different. So we have to write, okay, so these two are equivalent. Let me explain. Okay, they are equivalent. Okay, so what did I do? I just multiplied both with d. Okay, later I'll explain why did we multiply with d, right? So, but what is important at this point is this fraction and this fraction are equivalent. So they are representing the same thing. So if I have here, let's say a pi, okay, and this is the a over b, okay, this is just a different number, but it's still representing the same part, the same fraction. Okay, so that's what we mean by equivalent. Now, this one, c over d, is also equivalent to this. These two are now equivalent. Now, if you look, we can just cancel b here, right? And we'll go back to c over d. So if we have these two fractions, you can now see that they are of the same denominator. So that's our goal, to have the same denominator. And then if we have the same denominator, we can just add or subtract the numerator. So let me give an example again. Let's go back to our basic, 2/3 plus, let's have a simple one. Let's say 1/2. Okay. So our goal is to have this equivalent but the same denominator. So what we usually do in the arithmetic is to look for the least common multiple. So when we say least common multiple, 3, the multiple of 3 is 3, 6, 9, 12, and so on, right? The multiple of 2, 2, 4, 6, 8, 10, 12, and so on. Now, this 6 and 12, they are common multiple, right? They are both multiples of 3 and 2. 12 is also. But if you're looking for the LCM, LCM is the least. So the LCM should be 6. So what we are going to do now here is we're going to rewrite this fraction so that it has a 6 in the denominator. So what do we do so that we get a 6? So we just multiply 3 by 2. And we also have to multiply the numerator so that we are not changing anything, so that we end up with equivalent. So 2 times 3, 6. 2 times 2 would be 4. So that means this fraction is just equivalent to 2/3. I think you can clearly see. If you simplify, you get 2 over 3. And for the other one, I'll not be multiplying by 2, right? Because I need the denominator to become 6. So I have to multiply 3. And I have to multiply that to both numerator and denominator. So 1 times 3, 3. 2 times 3, 6. So now, since they have the same denominator, that would become 7 over 6. Okay, now you might be asking, what if you use 12 instead of 6? It's okay. You would still end up with a simplified of 7 over 6. The only issue that if you use 12 as the denominator, the only problem is you'll be dealing with a bigger number. But at the end, you should still simplify your answer and end up with 7 over 6. Okay, so what we are trying to do is to repeat this, but now using rational expressions. Okay, so if you notice, I didn't already give an example with the same denominator because it's simple. You just have to add or to subtract. Okay, now how do we do this? So if you notice here, I use a smaller number. But if you have a bigger number, it would be useful to factor. So hence, the first thing that you do is try to factor the numerator and the denominator. So again, factoring is very, very useful tool. So since this is minus, that means one is positive and one is negative. Now, you have options for 6, right? It can be 6 times 1 or 3 times 2. Now, this is negative. Again, it means different sign, but I'll be assigning the bigger number with positive since our middle term is positive. Okay? Then we can do the checking 3x and minus 2x. So when we simplify x, and that's the middle term, so we have the correct factor. So what if you will ask, Miss, what if I interchange this? Then you just have to do trial and error. So that's why it's called a trial and error factoring. Okay, so this is for the first one. For the second one, I'll use another color for this so that we can see it clearly now. So that would be x times x, since this is just 1. Okay. And I think I should make a correction here. This should be 3. Okay. Please, I have a correction here. It should be 3. So that's plus. Plus means you have to have the same sign. Okay, plus the same sign. Why am I using a plus? Because this middle term is plus. So the factors of 3 are 3 and 1. Okay, now, why did I use a different color? Because we have to look for the common, what we call the least common. In algebra, we use denominator, LCD, no, not LCM, denominator. Okay. So how do we find the least common denominator? So first, you have to look for the unique factors. Okay. So what are the unique factors? It's x plus 3. Okay, diba? It's unique. And you have x minus 2 and x plus 1. So that means this will be your LCD. So each of the factors there should be represented in your LCD. So yung unique factors. Okay? So that means I have to rewrite this. It's quite long. I will not multiply all of this together. Okay, I'll just write that in the denominator. That's your LCD. Okay. Okay. Now, if you compare, okay, so that's x plus 3x minus 2. So if you compare, what we did here is you have to multiply this by x plus 1 to get this denominator. So what we're saying here is you also have to multiply the numerator by x plus 1. So that would be the problem is x plus 2. But since we multiplied x plus 1 in the denominator, you also have to multiply x plus 1 in the numerator. Okay. For this side here, to get to this denominator, we have to multiply by x minus 2. So you also have to multiply the numerator by x minus 2. Okay, so that's it. Now that's how you have an equivalent fraction. So see, if you cancel this out, we just go back to our original problem. If you try to simplify this, okay? So we just multiply the numerator. Don't multiply this first. Now let's see if what will happen. So we are going to simplify this. So these two are equivalent, right? Okay. So we'll continue by multiplying the numerator and the numerator. So simplify this. Let me just write it down here. So that's x squared plus, you can either do the FOIL or the long multiplication. So you can pause the video and see, then plus, okay, I'll also multiply this, x squared minus 3x minus 2. Okay. Then we can have this as a single fraction already. Okay. I'm going to just write the denominator once. Then we can do common terms, no, or like terms. So you have here, we have 2x squared. Okay. Then positive 3x and negative 3x. When we simplify this, that will become 0. So this is where the cancellation, because the sum will be 0. And then this one is positive 2 and negative 2. Again, when you add up, it would become 0. So what you'll be left with this. And then for the denominator, so that means there's nothing to factor. We cannot factor x squared here, no. So we can just multiply this again. So I'll try to multiply this first, which is the first factor. That's x squared plus x minus 6. And then we multiply by x plus 1. So we just do the long division. Okay. So that's x squared times x cubed. Well, I'll just simplify the next line. I'll just do the long division. I'll just distribute this to all. So plus x squared minus 6x, and then I'll also multiply 1 to all of the term here. That's x squared plus x minus 6. Okay, and we're going to add and simplify terms here. X cubed plus 2x squared minus 5x minus 6. So this is our final answer. Okay, so that's it. So the next example that I have is a combination of addition and subtraction. Okay, so if you look at this one, actually this is fairly easier because there's nothing to factor here. So there's no common factor, there's no x squared, y squared. So there's nothing to factor for the next two. So that means I'll just see if we can factor this. So this one is you can leave this. Let's just factor the denominator. We're more interested first in the factor of the denominator, okay? So this is x plus perfect square and perfect square, x minus 2y and x plus 2y. So this is for the first fraction. So our LCD here will be the unique, okay? So you don't have to repeat, no? Because some people would make it x plus 2y squared because there's a 2 of that. No, you don't have to do that. You don't have to repeat, no? So this one is already represented here, and the other one is x plus 2y. So this will be your LCD. So if you notice, for your first fraction, you already have that exact LCD. So that means we're not going to multiply anything. We don't have to multiply anything because this is exactly the LCD. So we just copy the fraction. But for the second one, okay, in order to have this LCD, I have to multiply by x plus 2y. So I'm going to also multiply our numerator by x plus 2y. And then for the third one, our denominator is x plus 2y. So in order to have this LCD, I have to multiply by x minus 2y, and I'm also going to multiply that in the numerator. Okay, then what we do next is we simplify the numerator, we multiply, okay, I'll put a parenthesis first because this is minus so that I don't miss anything. So simplify, that's x squared, and then you can do the FOIL, so that's plus 3xy plus 2y squared, okay? Again, I'm going to just multiply this. So that's 2x squared minus 2 times 2, 4xy, okay? Then we can simply have one. You can write it in one fraction, so we have one denominator. Okay. Then we combine like terms. Okay, so I'm going to rewrite this. I'm going to show you here and take away the parenthesis. So this becomes negative x squared, negative 3xy, and then negative 2y squared. Okay, don't forget about that. Okay. Now, we just have to combine similar terms or like terms. So do we have x squared? But this will cancel out positive and negative. So that would become 0. How about the negative xy? So this is negative xy, negative 3, and negative 4. So that would become negative 8xy. Oh, I still have a 2x squared here. I didn't see that. Okay, the 2x squared here. Okay, I just canceled this, but I have a 2x squared here. And then I have 2y squared here. Okay, so then how do we know if this is already the simplest form? So again, you have to check if this is factorable. Okay, so what you can do, I'm just trying to this is what you do, no? In a scratch paper, you try to see if these are factorable. Okay. Looks like factorable, but it's not. Look, this is negative. No? Since this is already 1, there's no way for you to get 4 because the factor of 1 is 1 and 1. Diba? 1 and 1 is. So the factor of y is just 1 and 1. There's no option. And by using 1 and 1, there's no way for us to get 4. No? So there's no way for us to get 4. Okay, so I'll just have to multiply my denominator, and that's it. That's your final answer. Okay, you can no longer simplify this. That's your final answer. Okay, so that's an example for addition and subtraction of rational expressions.